This is Software Engineering Radio, the podcast for professional developers, on the web at se-radio.net. SE Radio brings you relevant and detailed discussions of software engineering topics at least once a month. SE Radio is brought to you by IEEE Software Magazine, online at computer.org/software.
Welcome to another show of SE Radio. It's Johannes Thönes in this time, and I'm sitting here with James Lewis. And I'm starting by reading his biography. James Lewis is a principal consultant at ThoughtWorks and calls himself a coding architect. He is part of the technical advisory board, which meets quarterly to produce the ThoughtWorks technology radar. James' interest is building application out of small, collaborating services, stems from a background in integrating enterprise systems at scale. James studied astrophysics in the 90s, but got sick of programming in Fortran. 15 years of DBA, software engineering, design and architecture later, he believes that writing the software is the easy part of the problem. Most of the time, it's about getting people's thinking right. So, welcome, James, on the show.
Thank you very much.
So, is there anything you would like to add to your biography?
I don't think so. I think that pretty much covered it. I've been at ThoughtWorks about 8.5 years now, so I've seen a lot of, I think, changes in the software industry in that time, because obviously everything's moving very, very fast. So, and I guess what we're going to talk about today is one of those latest changes.
Yeah. So let's just dive into the topic. We want to talk about microservices, and can you maybe start by just giving us an idea what a microservice is?
So, yes, of course. So a microservice, in my mind, is a small application that can be deployed independently, scaled independently, that can be tested independently, and which has a single responsibility. So this is on multiple axes. A single responsibility in the original sense, that it's got a single reason to change, or a single reason to be replaced if that's necessary. But the other axis is a single responsibility in the sense that it only does one thing, and one thing alone, and can be easily understood and is understandable by the people building and developing that service.
Yeah. What would be such a single thing be?
That's a good question. An example of a single thing, well, it might be a single responsibility in terms of a functional requirement, or it might be in terms of a non-functional, or as we've started talking about them, cross-functional requirements. So an example might be a queue processor. So something that's reading a message off a queue, performing a small piece of business logic and then passing it on. That might be something that's maybe a more cross-functional or sort of non-functional thing, or it might be something that has the responsibility, say, for serving a particular resource or resource representation.
Yeah, like a user.
So like a user, or say an article, or it might be a risk in insurance, or something like this, but something that's very, very focused, very, very small, and performs a single task on its own.
So I have the impression that microservices became quite popular in recent time. You've been talking about it. Other people have been talking about it. Why do you think is that so?
So that's a good question. Why have microservices suddenly seemed to have captured everyone's imagination? For me, the journey starts a little while ago, sort of around 4 years ago, where I sort of spent quite a lot of time at some workshops with people from various different communities in the software industry. So domain-driven design, some of the RESTful, some of the people involved in the RESTful community, in the REST community, the messaging community, and so on. And at these workshops, a lot of the questions that kept reoccurring, if you like, were around the size of applications, or seemed to me around the size of applications. So examples of that would be, we've got this big application. It's grown, it's been growing for 2.5 years, or 5 years, or 10 years, but we can't maintain it anymore. It's just too difficult to actually make any functional changes to it. Or we need to take this application we've got and somehow be able to deploy this into the cloud, software as a service, say. But at the moment, it's just impossible to do that. So as a result of that, the ideas of starting to split up applications into smaller cooperating components that are running out of process and talking to one another, which can be maintained separately, scaled separately, thrown away if you need to, has sort of evolved. But there's been this sort of community of practice almost that's been growing. Some of it based in London with people, coincidentally, who a lot of the people I've worked with. So Dan North talks about replaceable component architecture. He stresses the idea of replaceability in these systems. Fred George has also been talking about microservices for a couple of years now. So there's this almost like London community of practice around this. At the same time, of course, you've got the Netflixes on the west coast of the US who've been pioneering what they were talking about in terms of fine-grained service-oriented architecture. And in fact, Netflix are now talking in the same terms and using the same term, microservices. So they've got, so there's been a number of these different communities that have been growing over time and sort of demonstrating that this approach to building software is a viable one for production. And almost when you start to look at companies of the scale of Netflix, then almost like a necessity as they sort of grow. I think Adrian Cockcroft is on record as saying the reason they build systems in this way is because they want to be able to go as fast as possible. They want to be able to make changes as fast as possible. Bringing it back to the original question about why is it so popular now? Well, I think there's a lot of organizations that have built up some kind of debt over the last, 5 years. And they've realized that there's, in order to scale more, in order to be more effective when it comes to delivering software into production, in order to take advantage of things like continuous delivery, they need some approach which allows them to do these, to scale along different axes independently. And I think it's about the right time for an idea like microservices to take off, because there's a lot of companies facing the same problems.
You said something interesting
Sure.
about that people coming there with their large monolithic applications and split them up into microservices. Is this a typical form of introducing microservices?
That's a great question, and one I've actually been struggling with, because it relates to, it goes right to the heart of the question: do you start with microservices or do you refactor to them later? Empirically, most of the organizations have actually started with something big and have split big things up over time. Most of the organizations that are building what I would say is a sort of microservice style implementation. So you think about the Netflix, the canonical probably example of a lot of the patterns would be Amazon. So you think about Amazon, where they started with the big database and then moving towards service-oriented architecture. Netflix are in a very similar position. They sort of had a fairly big monolithic structure, monolithic application, and they split it out, moved towards this fine-grained service-oriented architecture. Actually,
do you know an example where you can talk a little bit more about to like visualize a little bit how such a split up of a microservice architecture happens, or into a microservice architecture?
Absolutely, yeah. So I won't name. I'm a good consultant, so I won't name clients. But there's an organization in the insurance world who I got involved with about 3.5 years ago now, and they were in the sort of absolutely classic situation where they'd built this really big sort of application. It was a typical N-tier style architecture where they had a big database, lots of logic in the database. They had some data services, this is the .NET world, so the kind of data access service layer over the top, and then above that they had another big application which contained a lot of the kind of business logic. And that the problem they had was this big application sitting at the top in the service tier. They included a lot of different products. So say they sold 6 types of insurance. They're very distinct product types. Each of them have distinct change cycles. Each of them, are more mature or less mature. And as the organization was growing, they wanted to be able to invest in growing different parts of these products and different products independently. Unfortunately, because they had this very big application, everything was tied together. So if they wanted to make changes, say, to their home insurance products, they had to wait on the change cycles for the motor insurance product. or if they wanted to scale the motor insurance product. Typically in insurance, motor insurance is very, very high volume compared to others, say life insurance. They had to scale at the point to the level of the motor insurance product. They didn't really have much in the way of flexibility. They also had ended up in a situation where they'd had to introduce sort of Byzantine or overly complex branching and merging strategies to enable the teams of developers that they had working on this application to work as effectively as they could without standing on each other's toes. Because of course, if you've got one thing, every time you make a change, it potentially impacts lots
Everything
of different
else,
areas,
yeah.
right? So they're in a pretty tricky position. And over the last sort of 3 years, they've been moving towards splitting out this application by product. So this is an example of how you might split.
Yeah. So they
applications
began
out.
splitting out with one small part, which then still talk to the monolithic application.
So in this case, actually, they didn't. In this case, what they did, so rather than do that and strangle it off gradually, they are sort of strangling it, but by building a new product off to the side independently. So they're
Okay.
they're not refactoring towards it per se, but they're actually, they've started with, okay, we need to now develop the home insurance part. So we're going to develop that as a separate web app, separate microservice. And in fact, internally, it was a CQRS implementation. So
Which is
in the .NET world, it's
yeah.
the command query responsibility segregation pattern.
Can you shortly explain what that means?
I can shortly explain that. Yes. So in this world, it's the idea of separating read from write, but also implementing data access and storage via either the execution of commands or queries to a separate read store. Typically, what you have is an event store that you execute commands on. Events get generated, which populate the read model, and then your applications read from the read model. So you write into one place and you read from somewhere else. And these components that were doing that, they were developed independently. They're running as separate services, as microservices. And then you have the application again, which is another one. So that would be a sort of a specific example of doing that. I know Groupon did a great talk. I can't remember the guy's name, but there was a great talk by one of the architects at Groupon at QCon March 2014 in London.
Yeah. We can find that out and put it to the show notes.
About how they've approached it, and they've followed a different approach. They're actually splitting up. I presume this is still true, but that they're actually splitting up an application on a page by page basis. So each they have a quote microservice that is responsible for serving parts of this of a single site rather than
and then connecting it to the old site.
Yes, yeah. So they in their case they are talking back to their Ruby, I believe it's Rails based API. Yeah.
Okay. Let's talk a little bit more about like how you do technically a microservice. When I gonna build a microservice for, let's say, the user authentication, what languages would I use? What standards do I build upon? And what do I need to make happen?
One of the whole guiding, I guess, principles behind this is that actually you get the freedom to choose a lot of the tooling on a case-by-case basis. So rather than it being you choose a particular language or particular back-end data store, say, for your entire product stack, for the entire product, you get the flexibility to make the informed decisions based on the right tooling for the situation at hand. There are no right choices. If you were talking about a user service, you could, and I have, as easily implemented it in C#, Java, or any other kind of modern programming language. At the risk of offending all the people out there who love JavaScript these days, personally, I'm not a huge fan. But and you can ask Martin Fowler if you ever see him why. But pretty much any programming language is going to be suited to doing it. The key thing, I think, is to make the stack lightweight. So rather than looking to use really, really sort of heavy traditional stacks, involving deploying into application containers, JBoss and Tomcat and these kind of big containers, to think about if you can use lightweight alternatives, so things like embedded Jetty, embedded Tomcat, Simple Web, or Webbit is another tool in the Java land. In Java land, .NET land is kind of an interesting place at the moment because obviously, traditionally what we've done in the .NET world is we've deployed into IIS, we've deployed all of our applications into this kind of managed environment. But even in the .NET world, there's been a movement to sort of bring in some of the learnings from the sort of Unix and Java communities around using embedded servers. So, for example, we're seeing more projects going on now that are using, say, NancyFX as an alternative to some of the web API or MVC frameworks, and then using things like Owen. So, there are alternatives out there in the .NET world where you can start to use more lightweight tooling around standing these applications up.
But when looking at the communication layer, everything is HTTP and REST.
I'm smiling. I'm a self-confessed fan of the RESTful architectural style. I think it solves a lot of the problems that we've sort of come to recognize when we've been doing integration over the last couple of decades. Well, for instance, things like I'd say things like versioning of resources and things you can address more easily if you're using things like resource representations and so forth. So, saying that, there is nothing in the microservices. There's nothing in the microservices world that says thou shalt be a RESTifarian and thou shalt always use REST. What I normally say to people is you should choose the right tooling for the job. If the right tooling for the job is to use message passing via bus for your because you've got specific cross-functional requirements around that, then that's what you should do. Martin and myself in the article we wrote called this out as a focus on smart endpoints and dumb pipes over a focus on having a big sort of service bus, traditional enterprise service bus, where you would hang services off the service bus. This is more about having these microservices with the smarts and the business logic in the microservices, which are talking via some application protocol, domain application protocol, or sort of interacting via a domain application protocol with other microservices. But the smarts stay in the microservices themselves. That's where the business logic is.
Yeah. So this smart endpoint and dump network is a reference to the Unix model, I think.
I think it could be read like that. I mean, I think the reason we chose that name was more around the enterprise service bus model. Certainly inside ThoughtWorks, for as long as I can remember, there's been a tendency to mistrust or distrust, rather, heavy iron, big iron, when it comes to doing integration. These sorts of things, they offer to solve all your problems. The kind of big enterprise service bus products, or they make lots of promises about solving all your problems. Personally, I've not seen an implementation of a quote service-oriented architecture with everything hanging off a central big, enterprise service bus. I've not seen one of these things succeed. So for us, I think it's trying to recognize that kind of centralization model, where you put in all your logic in one place and potentially in a big enterprise service bus, which takes care of everything for you, or certainly takes care of all these kind of routing and data transformation and all these sorts of things that you'd have to do to get disparate applications talking. Relying on one of these things to solve all your problems is in my mind not the right approach. There's a great talk by Jim Weber and Martin Fowler called "Does My Bus Look Big in This?", which they did as a keynote at QCon some years ago. And in that talk, Jim talks about the idea of the agrarian spaghetti box. So the enterprise service bus as the panacea for all your ills. His line on that is, it just makes your diagrams look nice, because of course you have these diagrams. You look at your enterprise architecture, and they've got all these crossing ugly lines, and it's really tempting to put this ESB box in the middle, because suddenly all your lines are straight. And that's a great thing if you're an architect. But of course, all the lines are still there. They're just in the middle of the spaghetti box, right? It just looks like spaghetti box.
But when all the routing is not done by the enterprise service bus, who does the routing? So do I need to do the routing?
You certainly need to understand more about how your applications communicate with one another. Yes, and of course, if you're building more services, in some ways, every problem, or you end up with many more integration level problems, right? Because when in the past we might have been unlucky and been talking to 2 or 3 external systems, say, now when you talk to one of your own systems, it's also an integration problem. So certainly you have to be much more cognizant of that. You have to understand much more about how applications communicate. Saying that, there are definitely approaches to doing that. The kind of things like event sourcing or event-driven applications, where you're kind of doing pub-sub, either using messaging or using HTTP and resource representation, say, allow you to decouple, so you're not just doing kind of point-to-point RPC the whole time.
Isn't that a bit like putting the complexity now from the monolith and how it works together on the networking layer?
The short answer to that is yes. And actually, when I originally talked to people about this, one of the great comments I got back was again from Martin Fowler was that we are shifting the accidental complexity, in the sense of the Fred Brooks use of the term, from inside our application, from the glue code that are components and our modules within our application, that glue code, the library code that they use to talk to one another and stitch themselves together. We're moving the complexity from there out into our infrastructure. And I think that's probably why this is, going back to one of the first questions, this is probably one of the reasons why now is a good time for this, because we've got many more ways to manage that complexity now. So if you look at programmable infrastructure automation, the movement to the cloud is ubiquitous, as the cloud being ubiquitous. Those sorts of problems, or the problems of understanding how many applications we have, how they're talking to one another, we've got better tools to address these things now. So
one of the things I noted from listen to one of your talks about microservices is that you said microservices need to be independently deployable without a container. So what does it mean, and especially what does it mean for infrastructure automation?
Yeah, so I have said that in the past. So I mean, it's as a lot of these things are, it's more nuanced than you tend to be able to claim in a 45-minute talk. The way I think about this is, you should be able to independently deploy the things that you need to independently deploy for the reasons that I was sort of talking about earlier. Do you need to scale them independently? Do you need to, either for availability or for throughput, latency reasons, and so forth? If you have those requirements, then you should be able to deploy them independently so that you can scale them. However, I do know organizations that deploy groups of these things in lockstep in some cases. So maybe there are 3 or 4 things that really you quite often share the same change cycles, so they actually are pushed out
like
at
the
same
user
time.
service and the authentication service.
Potentially, that might be one. Yeah, I mean, so in our case at the insurance company I was talking about, there was the read and write services were actually pushed out as part of the same release of that product. Then, in terms of what the impact of that is for operational for our operations teams and for things like build and deployment infrastructure, we need to be getting good at building software. We need to be better at building software. We need to be focusing on the ideas around continuous delivery from Jez and Dave's book, thinking about how we put our build pipelines together. So this is how we move our software from developer workstation all the way through into production. And also, in a lot of ways, there's this brings into this shift around thinking about mean time to recovery in production, and rather than the mean time to failure, which is the sort of traditional approach to managing systems.
So the book you mentioned is the continuous delivery book by Jess and by Dave.
Yes,
Yeah,
by
yeah.
Jez Humble and Dave Farley. Yeah.
And so what do you mean by discovery by failure?
So moving on towards
Yeah.
this mean time to recovery.
Yeah.
So yeah, there's some really interesting examples out there, and I might keep coming back to Netflix, I'm afraid. But a great example of this is how Netflix use circuit breakers in production. So the circuit breaker pattern's been around for quite a while. Obviously, it was either invented or certainly very popularized by Michael Nygaard in his book Release It, which incidentally is fantastic. One of the sort of best books I think out there on operations. What a circuit breaker in your software does is provides you a level of safety when you're talking to external systems. So in my code, I'll implement a circuit breaker such that if the downstream system that I'm integrating with becomes slow or goes away, and of course, as we all know, there is essentially no difference between being slow and not being there at all. These pieces of software, the circuit breakers, can trip and open, and then alert people that the downstream systems aren't available anymore. They also provide additional protection depending on the implementation. So things like avoiding thread pool starvation and not blocking incoming requests and so forth.
So when I got it rightly, when in Gmail I'm offline and it's say I will try back in 5 seconds, and then it goes up to 10 seconds, then it goes up to 20 seconds. That's an implementation of a circuit breaker.
That's exactly that's a perfect example. Yeah. So what that gives you then when you start doing things like monitoring and reporting on those is the ability in production to see exactly what's happening in your system at any one given point. And of course, if you've got, say, 10 collaborating services, that starts to be much more important, because it's very difficult to know if you've got 10 collaborating services. If a slowdown occurs, if response times to your users start to slow, where that problem is. So doing things like instrumenting your code with things like circuit breakers and using the circuit breaker pattern and then reporting on it allows us to focus our attention on problems immediately as they happen, and then to focus on fixing those as quickly as we possibly can. This idea of mean time to recovery, whether that's restarting servers, whether it's bouncing boxes, bringing new boxes up, or whatever that may be, is starting to become much more important. I don't think it's a coincidence that probably the most popular implementation now is something called Hystrix, also by Netflix. And Netflix have got 600 plus individual services in production. When you've got a landscape that's that operationally complex, then you need to do some things to aid diagnosis of problems in production, and to make lives easier for the people who are operating that environment.
Maybe changing topic a little bit, but building up on what you said, when they have a couple of hundred services, how big are these services? How big is a microservice?
That's something we've been sort of talking about internally for quite a while. I mean, I've seen them ranging from a couple of hundred lines of code up to a couple of thousand lines of code. For me, I think
but certainly not a million.
Certainly not a million lines of code. No. The question is, it comes back. The guidance I've been giving people, and the way I think about it personally is, does it do one thing and one thing only? It's difficult to imagine something that had a million lines of code doing one thing and one thing only, unless all it was doing was printing out a million lines of code of itself or something. I don't know. Which might be possible. Is that called Quine? I think it is. So in terms of the size of these things, the guidance is you should be able to understand them. They should have a single reason to change, and they probably shouldn't be more than a couple of thousand lines of code. Saying that, when you get to that point, the number of them becomes important. It's probably more important to think about how many of them that you're capable of supporting operationally than it is to think about how small they actually are. Yeah. Because it's better to have slightly bigger ones and fewer of them if you're potentially operationally a bit more immature, in the sense of you don't have fully automated deployment into production, push button, you don't have all the monitoring in place and so on. You have ops teams who are still learning and acquiring the skills necessary to work in the cloud and these sorts of things. In that sort of situation, it's probably better to focus on the number of them you have rather than their individual sizes, if that kind of makes sense.
Yeah, I'm wondering a bit, because you're talking a lot about single responsibility, and you mentioned domain-driven design in the beginning. Is microservices a little bit domain-driven design on the service level?
So if you've seen my talks online, I know you have. Yeah. So I often end the talks I give with this idea that, you know, of standing on the shoulders of giants, right? And for me, I think microservices is it's a coming together of a bunch of better practices from a number of different communities. So it's it's great stuff from the domain-driven design community around strategic design, bounded contexts, subdomains, how to separate out your domains into how to partition a bit, a very very big problem domain into smaller domains that you can manage them. It's also taking a bunch of the better practices from things like the operational and operational automation and programmable infrastructure, those communities, the DevOps communities, the cloud communities, the integration communities. I'm going to lump together a bunch of people who've been working with messaging, who've been working, building RESTful services, who've been working very hard to make people aware that you can solve integration problems using just the tooling available for free that drives the web, without having to invest in these sort of big iron pieces of kit. It's a bringing together of all of these different ideas into one place. So from the domain-driven design community, if I maybe roll back a few steps, because we're talking, at the moment about microservices in isolation, for me, the way you do quote architecture it has to be driven from the business and the business context. It has to be a top-down thing where you're understanding what the business problems are, you're understanding what the business landscape looks like, you're understanding what the business processes are, and then driving fit-for-purpose software products out underneath that. So, and for me, that's at the heart of domain-driven design, understanding what the business contexts are, understanding what the business domains are. One of my colleagues, Ian Cartwright, uses the great phrase, although potentially it comes across as very technical, the idea of business and architecture isomorphism. So this is the idea that actually, if you look at your business and you look at the design of your systems, they should be very similar. You should be able to look at the business and see your IT systems, your architecture, enterprise architecture. You should be able to look at your architecture and see your business. And if you're a technologist or a business person, there should be a recognition both ways that this is going on. There is a rather more controversial extension to this, which is that potentially we shouldn't have any IT at all, and that everyone should sit in with the business. But I won't maybe go into that. That's probably another hour-long conversation.
When you're talking about business, I remember you mentioned something about the neighborhood of microservices, and I wonder if that's a good way to group them.
The neighborhood?
Yeah, you said something around that, like if you want to group microservices, then you should group them either around business or around non-functional requirement, and you called that a neighborhood of microservices.
Maybe I've coined a new word today. And this is so exciting that I've almost forgotten I said that. Apologies. Yes. I mean, I think so. We've been talking a lot internally, and again, standing on the shoulders of giants, liberally borrowing from colleagues, building on their building on their ideas. There's this idea of town planning as the metaphor. If you've come across this is the idea that actually, your sort of the design of your system, rather than being like the blueprint for a house or a building, it's a bit more like a town plan. It's a bit more, it's a bit more about the zones in a town. So you have light industrial, you have commercial, heavy industrial, and so on, like residential, and then the connections between these zones are the kind of shared domain application protocols. The shared utilities, they all use the same water pipes. They all use the same electricity. They use the same street lighting and so on. So the trick, effectively, is how to create the map of the zones. Right. That's the trick. I actually favor a fairly lightweight approach to doing that, based on things like understanding business processes and then using lightweight techniques like, things like whiteboarding and using index cards with, capability names written on them and things like that, and grouping this sort of stuff together, seeing if it makes sense. But fundamentally, understanding what those groupings are is crucially important, and that has to start at the top. And this is where there's massive overlap, and learning from the traditional, more established service-oriented architecture community who've been doing great work in this space for a long period of time. So using all those lessons, how to subdivide things using the domain-driven design ideas of bounded context and subdomains, putting that together and then decomposing them into these individual applications.
Maybe going a little bit into that direction. I remember a colleague of mine saying, "Yeah, we are talking now about microservices because the term service-oriented architecture is burned." Can you contrast what we mean by microservices and what actually burned the service-oriented architecture, so that we are now talking about microservices?
So, first off, I'd like to make a distinction between the service-oriented architecture as a community as a whole and the implementation as I have experienced it in lots of different organizations, because I think there is a distinct difference. If you actually look back at the work that people have been doing in SOA, there's even there's a service-oriented architecture manifesto, for example. It's actually pretty clear, it's actually pretty sensible, and I don't think anyone can actually take much in the way of umbrance at it then. But then if you contrast that with the implementation that I think is, well, certainly my personal experience, and also the experience of many of my colleagues, and of industry, I think in general, there's a massive difference between the ideal of service-oriented architecture and the reality on the ground. The reality on the ground is a 10-year, $25 million program that runs for 2.5 years and gets canned. That delivers no value. The reality is spending millions of dollars on pieces of kit that will solve all your integration problems, and then those implementations never delivering. So I think it's really important to make that distinction between what the SOA community stands for and actually what the reality is. So I think the microservices idea is really about that reality, which is why I think it's no surprise it's been a community-led or it's been a bottom-up approach to building systems. A lot of the people involved have been or still are heavily involved as developers on teams who see the real problems day to day with either the amount of time it takes to make change or how difficult it is to scale things. And I've been looking for an approach that addresses some of these problems. I also don't think it's any coincidence that a lot of these individuals have been heavily involved in the evolutionary architecture, emergent design, and XP, the XP and Agile movements. Because what we're really talking about with the microservices model is a more iterative, incremental approach to building out systems of building out service-oriented architecture, or building out systems. And even that isn't new, because you can look back to Jim Weber talking several years ago now, when he was talking about guerrilla SOA as an approach to take to building out services in your organization, where you build out incrementally and release value incrementally as you go, rather than designing your entire service landscape up front, spending 8 months on a design document, handing it over the wall to an implementation team who will take 5 years and actually not deliver anything. So I think for me, the microservices style of building applications is intrinsically related to service-oriented architecture, because the service-oriented way of building systems is an eminently sensible way of going about building systems. I think the main differences for me are in the implementation details. So the decentralized governance models that these teams.
So no enterprise service bus.
Yeah. Yes. Yeah. So there's the technology choices. So favoring the lightweight lightweight solutions over sort of heavy, but also in terms of things like governance. So favoring lightweight mechanisms for governance, both technical and sort of human. So rather than favoring many heavy standards and standards bodies, favoring building up these standards internally over a period of time based on real use and real experience, or rather than have a top-down approach to these sorts of things, thinking about it from a team level and building up from the bottom.
Yeah. One thing I also heard is that in contrast to SOA, the services in the microservices architecture have a GUI. Is that true?
Can I just say no?
Yes.
No, I don't think that's the case at all. I think you can, in fact, I don't think there is anything implied about it that implies that you should have a GUI. I mean, I think actually it's quite useful to have a GUI, even if it's just telling you how your application is performing. But in terms of a user customer facing, yeah, exactly. But in terms of a customer facing GUI, no, there's nothing that says thou shalt have a GUI in a microservice.
All right. Let's talk a little bit about team. And I guess Conway's law.
Yes.
Can you talk a little bit about it and what it means for microservice architectures?
So this is another example where a practice or something that's been sort of evident for quite a while has sort of come together, been laid on top of other practices to produce something that I think is slightly greater than the sum of the parts. So Conway's law, I think it was 1968. Melvin Conway, he's in the west coast of the US, and he submitted a paper about his experiences with software, and I think it's kind of communication theory. What he described in the paper that he wrote was that the communication pathways of the software that an organization builds closely or exactly matches or closely matches the structure of the communication pathways within the organization itself. So if you've got a team of database administrators, a team of middleware people, and a team of UI people, what you end up building is a UI, some middleware, and a database. I thought I could attribute this quote to Dan North, but I asked him, and he said it wasn't him, it was someone else. But I'll sort of claim it was him. He said, if you write a 9-pass compiler, if you ask 9 people to write a compiler, you end up with a 9-pass compiler, which is another way of looking at this. So interestingly, that paper was turned down originally for publication, I think by Harvard Business Review. Then over a period of time, other organizations sort of repeated some of the research. I think Microsoft did some internal research and they kind of agreed with it. Then HBR, Harvard Business Review, finally repeated the research themselves, and they discovered that this was something that seemed to happen in software. So it was eventually sort of validated and has become known as Conway's law. The interesting thing is, of course, and what we've been calling at our technical advisory board meetings the inverse Conway maneuver, is it has implications not just for how you structure your teams and how you design your systems, but it has implications for actually how you reinforce boundaries between these things. So you can actually use team structures to impose boundaries in your software, or reinforce architectural boundaries.
To put it clear, what you're saying is one microservice should be full-time developed by exactly one team.
I'm glad you asked for the clarification. No, I'm not exactly saying that. I'm not suggesting that there should be a one-to-one mapping between microservice team. It might be a mapping between 3 microservices and a team. If those 3 microservices all live within the same bounded context, within the same domain, because I favor the team boundaries being the sort of more stable business capability boundaries. Those tend to be fairly stable in organizations, and this goes back to this business and architecture isomorphism idea. We should be looking at how the business works and structuring software so that it looks like that. Similarly, if you're structuring teams around that, then they can be cross-functional teams that look like the business model, if you like. It's a really interesting area that I think people are quite excited about exploring at the moment. The best example I've seen of it recently was a client I've been asked in to do some architecture consulting. And they have a big systems estate. They have a big portion of their software that's been written in India. They have a portion of their software that's been written in London. And you actually look at the software, the way the software in London and the software in India communicates, and it's probably the most decoupled of any of their systems. Over time, this is a fairly old system now. So over time, those individual bits have started to become maybe more temporally or behaviorally coupled. But the actual communication between them is still incredibly decoupled. Basically, they're passing messages back and forth, and that's a perfect example. The teams were on different continents, and actually, maybe that's something we can think about when we design our systems.
So if you want to decouple your modules or your services, decouple your teams.
Yeah.
Good.
Although the counter example to that was as another client, I was in the US, and it was the fairly typical cube farm model on a campus out of town, where they had 6 people working on a team on the same, probably what would be called some kind of service, but certainly the same application. 6 people all sitting different parts of the office, all in their cubes, who worked for 6 months and then came together and integrated towards the end. I think in that case, it was probably not the right thing to do to isolate them, because when they got together, it took them another 6 months to integrate their software, and I'm not even sure if it ever ended up in production. The problems were so horrendous.
So you should still see that your system works as a whole, which is a perfect lead over to the next question I have is, like, how do you test microservices? Because we know how to do unit testing, we don't know how to do integration testing on a single service level, but when you have a whole application of a couple of microservices, you want to ensure that they work together as well. So how do I test it? Isn't the test setup very complex?
This is probably one of the more difficult aspects. When we're building systems, we're always making trade-offs, right? If anyone involved in software knows that you make trade-offs in lots of different directions, this is one of the trade-offs that we're making when we're deciding to focus on things like scaling maintainability over time. Testing becomes more difficult. A lot of the systems I see also tend to end up using sort of event-based or event-driven models on top of the microservices, which again adds another layer of complexity, because suddenly you're not just worried about having to test lots more things in isolation. You're also having to worry about asynchronicity. Saying that, you get a lot of benefits as well, because you can test the small things in isolation. You can wrap a lot of tests around that small bit of code and actually verify it's working. It's working effectively. It's doing what it's supposed to be doing according to its sort of specification. The problems come when you've got behavior that spans multiple systems. So how do you test business processes, say, across multiple microservices? An example of that, I'm trying to think of a good example of that. An example of that might be, I want to create a user, say, but I also want to create a bank account. I've talked about this example before, because in my system, it's a banking system. I've got a bank account. I've got some kind of customer or user. And there's a business process which says when I create the user, they want to have a bank account associated with them, and I want to be able to send out some emails or some bank cards or something to them at the end of the business process. Now, using the microservice approach, potentially there's several different business capabilities there. You might have something that's talking about your customer, customer at the core type capability. You might have your transactional, your accounting capability, your account capability. You might then have fulfillment capabilities. Then you've got business processes which cross these boundaries. So how do you actually put tests around these things? And there are a number of different ways of doing it. So an example would be to have some kind of product level testing. So I have a product level flow across these different things, which I can execute automatically, and that involves having an environment that I can deploy all these things into and execute tests against them. There's also, and actually the more advanced, or the organizations that are further down the road, that are really inventing the new ways of building software. And I'm thinking the Twitters and the Netflixes again, and so on. They're actually moving towards a really interesting new model where actually things like performance testing, before you go live, all these sorts of things are actually sort of becoming past tense thing. Now we get stuff out there, and then we'll be testing in production. Our tests are actually performed by a small amount of our users in production. Obviously, after the actual functionality has been tested by, say, by the product owner and the team who owns those things.
And hopefully supported by good monitoring.
And supported by excellent monitoring and aggregated logging and all the other things that you need to put in place. But this movement towards, as I said earlier, mean time to recovery, the idea of semantic monitoring production, so actual running through user journeys automatically after you've deployed into production and so on. User journeys, being the path the user might take, a happy path through, say, a website. Those kinds of things are the boundaries are starting to be pushed on those by the bigger organizations.
All right.
You didn't ask me about versioning then, and maybe we should talk about that as well.
Yeah, all right. Then talk about versioning.
Because I think it's closely related to testing. It's because of course if you've got lots more of these things talking to one another, then making sure that they can still talk to one another as you keep deploying them is obviously more difficult than if you've got a method call. Similarly, refactoring across these things is more difficult, and so things like versioning becomes a much bigger problem than it has been in the past. How do you version the contracts that you're exposing to your clients? Again, there's a number of different approaches people are taking. So in some cases, people are using the idea of consumer-driven contracts and taking that the sort of next level.
So what is a consumer-driven contract?
So this is the idea, and this is an old, it's an old idea. If I've got a downstream system I'm integrating with, what I would normally do as a tech lead on a team, as the dude with technical responsibility, is make sure I've got a suite of tests that are exercising that remote service so that I know it's still meeting its contract with me, so I'm not going to break. That's the kind of thing I'd like to do. I'd like to run them automatically, so I know if any changes to that contract happen, then I'm aware of it and I can make changes to my own code. The idea of consumer-driven contracts is kind of flipping that on its head, and rather than me as the client of the downstream service running the tests, I still write the tests, but I hand them off to the service owners themselves, and they run them as part of their own build.
So you basically give them the possibility to run your tests against their system in their pipeline.
Exactly that. Yeah. So you give them an executable specification of how you expect as the client their system to behave.
Oh, okay.
And then on the other side, as the maintainers, the developers of the service that's being used, potentially by multiple clients, of course, I can take the set of these specifications, say, and as you say, run them as part of my build.
Yeah.
And almost my contract becomes whether I break any of the contracts of my upstream systems, which is a really nice idea. And that this has been taken further by there's at least two Ruby implementations now. One's called PACT, P-A-C-T. Can't remember what it stands for, but another one brilliantly is called Pacto. Because why not? One built in Australia, one built in Brazil. So I'm not sure what's going on. But people are starting to take this idea a bit further. Another approach to dealing with versioning, and this is a pretty crazy idea, is actually you deal with it via traffic shaping. So this is not necessarily at the public API boundary. I can talk about that maybe a bit later. But within your team, within your system, you've got teams who are structured to look after these microservices. This is certainly in the example of, say, the Netflixes or some of the other companies I've been working with. And as you're looking after these services, when you're making changes within your team boundary, then actually you don't have to worry so much about versioning, because the change horizon is much closer. I want to be able to make a change to the contract on a service that is only called from within the team really, really fast, because all it involves is me saying, hey, Dave, hey, Sarah, I'm going to make this change. Is that cool? And they say yes, right? And so you want to be able to make really, really quick changes there. But when you start to push out to services that have contracts with other teams, you need to have some kind of level of stability. Yeah. Now, what these, as I say, the Netflixes and so on have been looking at doing or are doing is using traffic shaping rather than explicit versioning. So saying, okay, well, and plus explicit versioning, I should say. So in this model, you have one version of your service that's running and is, quote, in production, the current production version. But then you deploy the next version of it also into production. You have two services in, quote, production.
Two different versions.
Two different versions of the services. But actually, the newer version, not live really, because it's not got any traffic, right? So then what you can do is you do all your testing against it. You make, you run your product level tests. You do make sure the product owner is happy with what's going on.
You maybe ask a few early customers on them.
Exactly, to get involved and so on. And then what you do is you start using traffic shaping to actually either to switch people over, or the teams upstream can choose when to switch.
Yeah.
And of course, now that we're moving to an age where cloud is ubiquitous, the idea that you can have many versions of the same thing running at the same time is much easier to kind of comprehend and to actually execute on, because we're not limited by the amount of tin we've got in a data center. Admittedly, we're limited by the amount that Rackspace or Amazon have got in their data centers, but still, you kind of get where I'm going with that.
Yeah. All right. Coming to an end, is there any question you would have liked me to ask you, or anything you want to just in generally say about microservices?
Yeah, I think so. I guess in closing, my comments would be to this idea of standing on the shoulders of giants. This is not necessarily something that's a completely new phenomenon. I don't think it definitely isn't, and I don't think anyone in the community is claiming that this is all of these ideas are new. It's building on a lot of existing ideas and putting them together in such a way that they kind of act as a kind of force multiplier. There's adding all this stuff together into one place as a kind of seeing it as a holistic whole, with team involved, with the ideas from lean, really talked about lean and product teams and these kind of things, with ideas from the service oriented world, with ideas from the DevOps world, programmable infrastructure. Putting all that stuff together makes, I think, a pretty compelling vision for how you actually start building systems, for now. There's a lot of people who've been involved in this, and maybe some shout outs would be appropriate if that's appropriate. So I mentioned earlier, Dan North has been very involved with the idea of replaceable component architectures. Fred George, Adrian Cockcroft at Netflix has been talking extensively around this. There's certainly some big organizations in Australia. My colleague Evan Botcher, who's been leading some efforts over there. Compare the Market, who've been doing a really interesting job in the UK, transitioning from one thing to another. And it's a pretty exciting time, I think, in how we're learning to build software in this kind of in this new world where the cloud is ubiquitous. And I think that's the key game changer when it comes to building applications these days. And we haven't even scratched the surface of how we can build systems. I think the craziest thing I've heard in a long time is that, for example, Netflix don't have DR, right? How do you do business continuity when the number of machines you're running is into the tens of thousands? Who else can? Where's your backup plan, right? That's something that was anathema 5 years ago. Is certainly an anathema to most CIOs. I would imagine at the moment. We're still learning about how to do this stuff, but I think some of these ideas have got some legs, and hopefully we'll see some exciting stuff going forward.
That's great. I wonder where our listeners could find out more about it. I heard you are involved in writing a book.
Yes, that's right. I am. Well, first off, obviously, there's Martin and my article, which is probably worth a look. That's on martinfowler.com.
I'll link to everything you say.
Okay. My blog, which I very rarely post to, I'm afraid, but does have details of things like talks and tutorials and so on, is at bovon.org. There's a slightly long and involved story about nuclear physics there, which I won't go into on just at this time. There's, as you say, there is a book in the works that I'm looking at the moment. But in the meantime, I know that also a colleague, Sam Newman, who has also been heavily involved. In fact, the two of us, you could almost argue, have been the sort of two in a box in ThoughtWorks behind some of this stuff. He's got a book that should be, I think it's in early access now at O'Reilly. So I think he's hoping to get that out before Christmas. So obviously take a look at that. Take a look at the open access version of it. Apart from that, the Netflix blog is a fantastic resource for understanding the journey they've been on and some of the things that actually become possible when you start to focus on, when you remove the boundaries and really start to focus on building software at scale. That's pretty exciting stuff. So there's probably a bunch more. Yeah.
All right. And where can people find out more from you? Are you on Twitter?
Yes, of course, I'm on Twitter.
Yeah.
My tag is Boicy, Boicy. So yeah, you can get hold of me there. You can also email me. The address is on Martin's site at the bottom of the article. We would really like to collaborate with people as we understand a bit more about how to build systems this way. So, I mean, if you're interested, please get in touch.
Yeah.
I'll do my best to answer any emails I get.
Yeah. Any talks post October, which is the probable release date of this show?
I think I'll be speaking. In fact, I am speaking. The reason I say I think is is because I can't remember the exact dates, but I'm speaking at Go to Berlin on this topic.
Uh-huh.
So there's a great track. I think it's going to be really exciting, actually. Alex Grosser has got a track on. It's a kind of face-off, monoliths versus microservices. So that should be a really interesting track. So I'll be in Go to Berlin. Post that, I'm not entirely sure. I think I'll probably be focusing on the book leading up to Christmas. So yeah.
All right, then we look for a microservice heavy Christmas.
Yeah.
And thank you very much for your participation in the show. It was very interesting. All James mentioned, you don't have to type it in by listening. I will prepare the show notes. We as SE Radio would really like if you could give us feedback to this show. So maybe write a comment in the blog or write in iTunes. For instance, what you like the most and the least on this episode. And that's for me to say goodbye. That's Johannes from SE Radio. Ciao.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more information about the podcast, including other episodes, visit our website at se-radio.net. To support us, you can advertise SE Radio by clicking the Dig, Reddit, Delicious, or /dot buttons on the site, or by talking about us on Facebook, Twitter, or your own blog. If you have feedback specific to an episode, please use the commenting feature on the site so that other listeners can respond to your comments as well. This and all other episodes of SE Radio is licensed under the Creative Commons 2.5 license. Please see the website for details. Thanks again for your support.